And if you want to have a look at the output, we can see, okay, the criterion for a definitive solution is the mean relative error is smaller than 1 over, what's that, a billion. And we set this 1 over a billion to the convergence epsilon. And it says, okay, well, this is our convergence criterion. We needed 5 iterations to meet this. And here we see, so after the first iteration, we said, okay, we got it wrong. This is the mean absolute error, which is quite small, you could argue. And then it gets smaller and smaller, iteration by iteration. And in the end, we are sufficiently small. Good. Of course, again, as I said before, you have a choice in the convergence criterion. So if you would rather have, the maximum error to be smaller than a given value, this is of course also possible in the final step. Just, depends on how you calculate your convergence criterion. And lastly, I wanted to show you, just let's not go through the code because plotting sometimes can be a bit messy, and this manipulate function is quite fun to play with, but is not necessarily intuitive to set up. So let's just talk about the result here. So you have here 3 plots, and here time on the x-axis, twice time, twice our capital and our consumption on the y-axis, and this last third plot shows us, okay, the trajectory, right? The optimal trajectory of to steady state, which is a graph depicting k on the x, and so capital on the x and consumption on the y-axis. And this linear, so this line here is this linear convergence trajectory that we initially guessed. This is what I meant. And this is the solution. The blue one is the solution, and we would now basically play with this iteration, this number of iterations to see, okay, the initial guess is blue. After the first iteration, we get the red dots. The red dots is kind of the in-between solution. So after one iteration of the loop, we get already it's much closer, as you see. The red dots are much closer to the blue dots than the green dots. And then after the next one, we're already kind of good. And then as you increase the number of iterations, they basically become indistinguishable. And this is basically it. So then you have another way to display the solution as the grid points here, right? So the grid points that are now not mapped between 0 and 1 as it was here in the time here. T is between 0 and 100. We decided to have 100 grid points, but now we can also, of course, have a transformation of T and transform it not back to the 0 to infinity timeline. And this is exactly what I did here. So you have all the time periods starting from today and then our initial guess, and the optimally chosen consumption for our initial guess, and go all the way down to infinity where we converge to the steady state. And this is basically it. This is solving the Ramsey-Cass-Koopmans model using the relaxation algorithm.